Welcome to the first lesson of Bowman Students Union. I'm Don Jaira Colbert. I will be teaching solving inequalities today. So we're going to hop straight into the first problem. I'm using the sheet from Mr. Pera. It's page 3 of the take-home test. For the first problem, we have 0 is greater than 3x minus 3 minus 6. So when you're tackling a problem, the first thing you want to look at is your like terms. I see that minus 3 and minus 6 are the only like terms in this expression, so I'm going to combine them. Negative 3 minus 6 is negative 9. If you're like me and find negatives a little confusing, you can always put this directly into a calculator and it's going to give you the answer. Don't mistake this 3 as a positive 3. Any number that has a negative to the left of it is a part of that number. So this will always be negative 3 and this will always be negative 6. After that, we're going to drop everything else. So 0 is greater than 3x. Now that all of our like terms are combined, the first thing we're going to do is add 9 to both sides. That's because the goal is to isolate 3x. And in order to do that, we want to get rid of anything on this side of the equation that's not 3x. So right now it's 9, and that's why we're adding 9 to both sides. 0 plus 9 is 9. We're going to drop the greater than sign. 3x. Negative 9 plus 9 cancels out. Now we have 9 is greater than 3x. Remember, our goal is to find the value of x. And in order to do that, we want to isolate what's ever happening to it. Right now, x is being multiplied by 3. So we're going to divide both sides by 3 in order to get the answer. 9 divided by 3 is 3. We're going to drop the greater than sign. These 3's cancels out. And we're going to get x is less than 3 or 3 is greater than x. Both ways of saying it is fine. Now, let's move on to problem 2, because problem 2 immediately gets a little more tricky. We have 4x plus 1 minus 1 is greater than or equal to negative 8. Now, just like we did in the last equation, we want to ask ourselves, what are the like terms? We have 4x on this side, but nothing else has an x on this side, so 4x is already by itself. We have negative 8 on this side, and there is no other integers on this side, so the 8 is already by itself. However, positive 1 and negative 1 are both integers, therefore these are our like terms, and we want to combine them. Now, the reason it can get a little tricky is because, again, working with negatives is sometimes confusing. However, anytime you get confused, put it directly into a calculator. If you put positive 1 minus 1 into a calculator, you're going to get 0. Therefore, we can put 4x plus 0 is greater than or equal to negative 8. Or, since it's 0, we can just completely cancel these out, which I think is going to make this a lot easier to read. Now, just for the purposes of this video, I am going to include the 0, just so you realize that the next step is going to be getting rid of the 0. You're going to have to get rid of the 0 no matter what. And that's why I said, instead of putting 0, you could just cancel these out since you already know the value is 0. So we're going to drop everything else. We drop the 4x, we drop the greater than or equal to sign, and we drop the negative 8. Now it's pretty straightforward. X is being multiplied by 4, so we're going to divide both sides by 4 in order to isolate x. So these two 4's cancels out, and you're going to get x is greater than or equal to negative 2, because minus 8 or negative 8 divided by 4 is negative 2. Now, when I really didn't understand algebra, I wish that someone explained this to me because it would have helped me a lot. Now, you can skip this part if you want, but I'm still going to show it just to teach you all why this works. a lot of people might ask, why do the 4's cancel out here? What exactly makes the 4's cancel out? Well, let's actually do the problem. We have 4x divided by 4. Now, when you're multiplying something with a variable like x, y, or z, the only way that x can be divided is if there is another x in the equation. However, notice that there isn't an x on the bottom, so the only thing we're dividing are the 4's. So let's do it. 4 divided by 4 is 1, and we drop the x. 1x is the same as x. The reason we don't include the 1 is because it's a lot simpler to read when it's just x, and it's a lot easier to understand when it's just x. One more thing I wanted to preface. Out of all things, why did we divide both sides by 4? Why couldn't it work if we just multiplied both sides by 4? We're going to have 4 times 4x, which is 8x. And we're going to have 4 times negative 8, which is going to be negative 32. And you see, we didn't successfully cancel anything out. Before we got our answer, I said that x is being multiplied by 4. And division is the inverse of multiplication. So anytime we match something to its inverse, we're always going to get a result that cancels out. I will probably make a separate video going into depth on that, but I did just want to show you real quick. Now, I'm going to go on to a problem that's a little bit tougher, but we're following the same concepts. The only difference is you have to be really careful. So for problem 6, we have 2p minus 4p is less than or equal to negative 2. Once again, let's look for like terms. We have a number with p here, and we have a number with p here. That means that these are both like terms, and we need to combine them. Now, remember what I said. Anytime there's a minus to the left of a number, it's a part of that number. So don't think of this as positive 4p and say, oh, okay, let's combine the two. 2 plus 4, okay, that's 6. So we have 6p is, no, don't make that mistake. This is not 4p, this is negative 4p. So if we put 2 minus 4 into a calculator, we're going to get negative 2, and then we just add p. Now we're going to drop our less than or equal to, and we're also going to drop the negative 2. P is being multiplied by negative 2, so we're going to divide both sides by negative 2 to get the answer. Now, this is where you have to pay close attention. Again, these cancel out because negative 2 divided by negative 2 is 1. That's going to give us 1p, and 1p is the same as p. That's why they cancel out. So we're going to have p, and then we ask ourselves, do we have to flip the sign? We do. So this used to be less than or equal to, but now it's greater than or equal to. You have to flip the sign anytime you divide it by a negative number. We divided both sides by negative 2, which means we have to flip the sign. Now let's say this was a different problem. Let's say we had 2p is less than or equal to 2. Divide both sides by 2. Notice how the sign remains the same. That's because we didn't have to divide by a negative, but since we divided by a negative, we must flip the sign or the answer is going to be wrong. So we flipped our sign. Negative 2 divided by negative 2 is positive 1 because 2 negatives give you a positive. Now I'm going to move on to a problem that has increased the difficulty, but we're following the same concepts. For this, I'm going to be using number 11, and in that problem, we have a minus 15 is greater than negative 4 times minus 6 plus 3a. Also, sometimes I switch between the word minus and negative. Personally, I always say minus. Like, I would normally read this as minus 6, minus 4, and minus 15. But I know that could be a little confusing because most people would read this as negative 6. So just so you're not confused, when I say minus or negative, I mean the exact same thing. So this is the time where we ask ourselves, what is the order of operations? PEMDAS. Parentheses, exponent, multiplication, division, and addition and subtraction. Now, according to PEMDAS, we have to assess the parentheses first. In our case, these are our parentheses, and we have to solve for the parenthesis before we move on to anything else. And we're going to do that using distributive property. Now, if you aren't too sure how to use distributive property, I may make a separate video on that. But for now, minus 4 is going to be what we're distributing. So negative 4 times negative 6 is positive 24, because a negative times a negative is a positive. And then negative 4 times positive 3a is negative 12a, because a negative plus a positive is a negative. It sounds confusing at first, and it definitely was for me. But like I said, if you put this directly into a calculator, it's going to give you the same answer. You put negative 4 times negative 6 into a calculator, it's going to give you 24. You put negative 4 times 3 into a calculator, it's going to give you negative 12. And at that point, you just have to remember to drop the a. Now, since we solve for our parentheses, we can drop every other number. So a minus 15. Now, in case you wanted to look back at PEMDAS, we don't have any exponents here, so we can skip that. We don't have any multiplication left, so we can skip that. We don't have any division left, so we can skip that. And addition and subtraction are interchangeable. Meaning, if you have a problem with only subtraction left or only addition left, you no longer have to use PEMDAS. So let's erase it. So now it's pretty straightforward. We don't have to combine like terms because there are none on any sides of the equation. We have an a here, and we have an integer here. We have an integer here, and we have an a here. So it's no like terms. We're going to immediately start by isolating a. So to have a by itself on this side of the equation, we're going to get rid of 15. So we're going to add 15 to both sides. Sorry, I was trying to get some somewhat straight line. And we're going to have a. These cancel out. We're going to drop the greater than sign. 24 plus 15, 6, 7, 8, 9 is 39 minus 12a. Now, we've already decided to have a on this side of the equation. So to get 12a on that side, I'm going to add both sides by 12a. A plus 12a is 13a. Drop the greater than sign, and we're going to drop 39. Now, we're going to divide both sides by 13 to get a by itself. These are going to cancel out, and we're going to have a is greater than 39 divided by 13, which is 3. Also, I kind of assumed most of you all already know how to graph, but let's say you didn't know how to graph a is greater than 3. You're going to have a number line, 0, 1, 2, 3. So this looks like your common number line. Greater than or less than, you use an open circle. Greater than equal to or less than equal to, you use the closed circle. So since we have a is greater than 3, we're going to put an open circle over 3, and greater means it's going to shift to the right. Now, for the last problems, it's pretty much the same concept, but I want to include it because I seen there was some confusion about x equaling 0 and x having no solution. X equals 0 and x equals no solution are completely different. The reason being is we have to think about this as a graph or a number line. If x equals 0, we're going to have a point right here on a number line. Sorry if this is a little bit sloppy, but our point is going to be right here on a number line. If x has no solution though, where do we plot it on a number line? Well, nowhere. And that's really the difference between no solution and x equaling 0. So with that out of the way, let's solve problem 18. We have negative 6 times 1 plus 2x is greater than or equal to 6 times 2x minus 1 plus 2x. Now, again, following PEMDAS in order of operations, we're going to solve for the parentheses first. The reason this problem looks very intimidating at first is because it has multiple parentheses and it looks all over the place. But after we solve for the parentheses, it should look a lot more familiar. So minus 6 times 1 is minus 6. You can put that in a calculator. Negative 6 times 2x is negative 12x. Because we have a negative and a positive gives you a negative, is greater than or equal to 6 times 2x. Sorry, let me put my lines here just so you're not confused. Is greater than or equal to 6 times 2x, which is 12x. And then 6 times negative 1 is negative 6. And now all we do is drop the plus 2x. So now we're going to look for our like terms. This number contains an x, and this number contains an x. So we have to combine 12x and 2x. Now remember, I said whatever sign is to the left of a number is a part of that number. So this is 12 plus 2, essentially is how you should think about it. So 12 plus 2 is 14, and all we're going to do is drop the x. After that, we can drop the negative 6 and everything else in the problem. Now we have negative 6 minus 12x is greater than or equal to 14x minus 6. Now, we want to get x by itself. So we're going to get rid of the 6 over here. Keep in mind, this is negative 6. So we have to add by 6 to both sides to get negative 12x by itself. Now notice how both of these actually cancel out. So it might seem confusing at first, but if you just follow the principles and follow the rules of algebraic equations, you're going to get the correct answer. So we're going to get negative 12x is greater than or equal to 14x. All we did is drop everything down and canceled out 6 so far. Negative 6, sorry. Now this looks really confusing because you have x on one side and you have x on another side. You don't have 14x plus 2. So visually, this looks very unfamiliar and very foreign, but all you have to do is follow the rules of algebra. If you have x on one side of the equation and x on another side of the equation, you have to get rid of one of them. So we're going to get rid of 14x by subtracting both sides by 14x. Notice the 14x over here cancels out, and we have negative 12x minus 14x. That's how you should think of it. If you put this directly into a calculator, it's going to give you negative 26x. We're going to drop the greater than or equal to, and guess what? We don't have anything on this side, so we put 0. That's the part a lot of people may feel confused by. This is simply 0. If we canceled out everything on this side of the equation, a lot of people might get stuck and say, well, what do I do now? Just put a 0. Now, that doesn't mean we're not going to follow the principle. We're still trying to get x by itself. So we're going to divide both sides by negative 26. Now, just like previous problems, we're going to drop the x, and we're dividing by a negative, so we have to flip the sign. Even though this problem is really unfamiliar, it's obscure, we're dividing by 0, so our answer is going to be 0, but nonetheless, we still had to flip the sign because we divided both sides by a negative. So your answer is going to be x is less than or equal to 0. On a number line, it's going to look something like this. So the one they provided is negative 2, negative 1, 0, and then I'll just do 1, 2, 3. Since it's less than or equal to, we're going to use the circle. It says 0, so that's why we put it on 0. And if it's less than, that means we need to shade our line to the left. So thank you for watching the first lesson by Bowman Students Union. If you benefited from this video, make sure you leave a like. And also, I will be looking in the comments, so any part that was confusing or any part that you want me to clarify, feel free to drop it down below. Also, don't forget to join the Reddit. That's where I post not only tips, but also the answers to a lot of the worksheets, and then I spend my time on YouTube actually describing how to solve those worksheets. We also just got done creating the Discord, so make sure you join it. I will put the link in the description below. Other than that, thank you for watching.